So, first things first, draw yourself a set of axes. Then you're going to need a pair of lines at the +1 slope and -1 slope, at going up at 45 degrees and going down at 45 degrees. Then you're going to need lines at 30 and 60 degrees as well, and I'm just drawing them in the first quadrant first, and now I'm going to add them to the other quadrants. Okay, so now we have everything labeled in degrees: 0, 30, 45, 60, 90, 120, 135, 150, 180, 210, 225, 240, 270, 300, 315, 330, and back around to 0, which is also 360. Now I'm going to label them in radians. Okay, we're going to start at 0, which is also 2 pi. Then we show pi over on the left hand side at halfway around, pi over 2 at straight up on the y-axis, and 3 pi over 2 on the bottom. And then we'll have pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Then we're going to have at 30 degrees pi over 6, at 60 degrees 2 pi over 6, which we can also write as pi over 3. At 120 degrees we have 4 pi over 6, or 2 pi over 3. At 150, 5 pi over 6, which is just 5 pi over 6, 7 pi over 6, 8 pi over 6, which is 4 pi over 3, 10 pi over 6, which is 5 pi over 3, and 11 pi over 6 before we get back around to 12 pi over 6, which is 2 pi. Now we're going to talk about how to find the cosines and sines of all of these. Okay, now I'm showing a picture of just the upper right quadrant to simplify things a little bit, with the angles labeled, which is 0, pi over 6, pi over 4, pi over 3, and pi over 2. Now, for cosine, you're first going to just write, counting down, starting at the axis here, the numbers 4, 3, 2, 1, and 0. Then next to those, for sine, you're going to count up 0, 1, 2, 3, 4. Now over every one of those numbers, counting both directions, you're going to write a square root. And then for each of those numbers, you're going to write it over 2. So for the cosine, this will be the square root of 4 over 2 at 0, square root of 3 over 2 at pi over 6, square root of 2 over 2, square root of 1 over 2, and the square root of 0 over 2. Sine will count up, square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, and square root of 4 over 2. Now I know these aren't the numbers that you're used to, but the point is that this makes a regular pattern of it, so all you have to do is write 4, 3, 2, 1, 0, counting down for cosine as it goes up and around, and 0, 1, 2, 3, 4 counting up for sine as it goes up and around. And the secret to this, of course, is that the square root of 4 over 2 is just 2 over 2, which is 1. The square root of 3 over 2, well, that's the right thing. Square root of 2 over 2, the same. Square root of 1 over 2 is just 1 over 2, or 1/2, which is correct. And of course, the square root of 0 over 2 is 0 over 2, which is just 0, which is what we expect for cosine at pi over 2, or 90 degrees. Now for sine, it's the same thing. That's really a 0, and a 1/2, and a square root of 2 over 2, and a square root of 3 over 2, and a 1. But those are the correct values. Now when I expand that to all 4 quadrants, all that really happens is that because the cosine, which is the first number, represents the x value, sometimes called the run, it goes 4, 3, 2, 1, 0, and now we're talking reverse because we're to the left of the y-axis, -1, -2, -3, -4, and then it comes back -3, -2, -1 to 0, 1, 2, 3, and back around to 4. Sine, because it represents the rise or the height, goes 0, 1, 2, 3, 4, then falls back down to 3, 2, 1, 0, and now becomes -1, -2, -3, -4, and then -3, -2, -1, and back to 0. And of course, every one of these gets the square root symbol written over it and then gets divided by 2 to produce the numbers that you expect. So you can, with this relatively simple formula of just counting 4, 3, 2, 1, 0 and 0, 1, 2, 3, 4 and copying to the other quadrants, you can produce an entire unit circle just remembering the numbers 0, 1, 2, 3, 4.